Hello, I'm Daniel Bryant, co-host of the InfoQ podcast, news manager here at InfoQ, and product architect at DataWire. And I recently had the pleasure of sitting down with Bryan Liles, senior staff engineer at VMware. Bryan is a well-known figure within the cloud and container ecosystem, and he's the co-chair of a KubeCon event that is run by the Cloud Native Computing Foundation. In Bryan's recent roles at Heptio and VMware, he's been researching ways to make Kubernetes easier for developers, and so I was keen to learn more about this. I also went to ask Bryan about an open source tool that he and his team have recently been working on named Octant, which is a highly extensible platform that facilitates developers in better understanding the complexity of their Kubernetes clusters and applications. This tool shows great potential in joining up the related topics of understandability, observability, and debugging, which is very important when working with cloud-native technologies and complex distributed systems architectures. On a related topic, I was keen to explore what Bryan thinks the future of Kubernetes is and what role serverless technologies may play here. As a couple of bonus questions, we discuss the relationship between Ruby on Rails and Kubernetes, and we also get a couple of great book recommendations from Bryan too. So hello, Bryan, and welcome to the InfoQ podcast.
Thank you for having me.
A lot has happened professionally for you in the past year that I've seen on Twitter, from Heptio being acquired by VMware and now Pivotal, obviously joining that party. Could you give us a bit of a summary of your professional journey?
I have done all bits of cloud, from creating servers, serving people's software before there was a thing called the cloud. I also worked at the first company who did software as a service as a real thing, invented the term. I actually helped build a cloud with DigitalOcean, and that brings us up to 2016. I wanted to try something different, so I went and worked at a large bank and realized a couple things. One, it's interesting to see what a large group of people can do. And two, banks are interesting, but not interesting for me. And during that time, I was looking to go do something else and not be in management. And I had run across Heptio in the past, and I interviewed with them at that point. And 2 years ago, basically almost exactly 2 years ago, I was hired on to Heptio. And I worked there for a year, and I had this pretty interesting research project around creating better configuration abstractions for Kubernetes. Yeah, it sounds complex, called KSonnet, but we retired that. And at the same time we were retiring that, VMware is like, well, you also join us. So we went through that. I think that deal closed in about December of last year. So I've been at VMware ever since. And now at VMware, I look at developers who are using Kubernetes, and we're researching methods to make Kubernetes easier to use for developers.
Very cool. One thing I've noticed sort of working with people on Kubernetes is when you turn up to the Kubernetes ecosystem, there's actually quite a lot to learn. There's quite a lot of I think if you've been in it for a while, you just accept pods, you accept nodes, all the kind of common parlance. But what do you think is the biggest hurdle for someone, say, from the world of VMs or whatever, arriving at Kubernetes? What's the biggest hurdle for them learning how to use the platform best?
Well, the problem with Kubernetes is the problem with everything else. It's new and it's complicated. There's lots of moving pieces to Kubernetes. And in many cases, they're required. Kubernetes works in the cloud. It'll work on your Raspberry Pi. It'll work in your data centers. It works in many types of storages and networking systems. So there are a lot of pieces there to make it work. But a good analog would be the first time you sat down and you had to query a database, a relational database using SQL. You select from star, whatever. But then you have to learn about joins, and then you can learn about distinct, and you can learn about grouping, and then you can learn about subselects and indexes. Now think about that. It's super complicated. Kubernetes is no different than any of that. It's just a complicated system that can do a lot of things. And because it's different than how we've approached computing before, people shy away from it or are scared to start.
Makes sense. And I know you're working on some tooling to make it easy for folks as well. So I bumped into Octant. I saw you talking about that, I think, on Twitter recently. I'm guessing that tool is aimed at helping people on their Kubernetes journey.
Yeah. So Octant has an interesting story. Over a year ago, we were thinking about what is hard about Kubernetes. And one question that kept on coming up is, well, is something broken? And that's a pretty innocuous question, but if you think about it in Kubernetes, how do you troubleshoot an application? Well, you use kubectl, which is the command line utility for Kubernetes, which is literally a Swiss Army knife. It does a whole bunch of things. And you can use kubectl get. Well, kubectl get what? Or you can use kubectl describe. Well, kubectl describe what? So what we started to do is like, well, you know what? We can figure this out. We know that there are objects in Kubernetes, and we know how they behave. And if we know how they behave, then we can detect if they aren't behaving in a way that we think they should. And more interesting is that we can actually build up a graph. We can show the connections between objects in Kubernetes, whether they are implicit or explicit connections. So with that, we can actually tell you what's going on and what's wrong. And then quickly after we built that tool to show that it would work, then we realized that, well, now we need all this context. So we built this dashboard around Octant. So Octant is a tool that has a dashboard, has a thing to allow you to see what's going on and what's wrong in your application. And we're also building it out with this system of plugins that can solve problems that we don't even know. Put your CI CD on there. I don't know, have security, do other types of workflow.
Very cool. Is it a desktop app, Brian? Web app? How does it roll?
So Octant is interesting. So a lot of Kubernetes tools and dashboards before were installed in your cluster. And the way you would access them is either they have some kind of super user privilege or you would have to upload your credentials. Both of those are hard. The super user means that if there's an issue, you will get into a newspaper. And guess what? Someone ran into an issue with the Kubernetes dashboard and got into a newspaper. And then also, if you upload your credentials, that does work, but then it's not friendly to the user. So Octant, as of right now, runs locally on your machine and it can use your local Kubernetes credentials. It can actually just figure out where the defaults are. And it presents a web page. We're actually moving this to an application to further cement that, to show people that you click on an application on Windows, Mac, or Linux, and you get an application that you can explore your clusters with.
Very cool. So you mentioned the kind of debugging use case. Do you think it also might be useful for just understanding what you've got? I mean, working with kind of complex distributed systems these days, even a small number of microservices I often find is quite challenging. So do you see it only being a debugging tool, but maybe hey, you've just joined the company, here's Octant, knock yourself out, get started understanding the landscape?
Yeah, actually, so it's a debugging tool, but it's also an exploration tool. And that's why we built a dashboard. So you can click to follow an object. And if that object is linked to another object, you can click to follow that object. And what it's built for is to allow the users to discover what they need to discover. And we're helping the whole entire time by giving you the information that you need in the particular context that you're in. So if you're looking at pods, you get pod stuff. But if you're looking at CRDs, which is really hard, and for those of you all who aren't familiar with Kubernetes CRDs, little sidebar here. Kubernetes is basically an API of APIs. It breaks down to that. But with Kubernetes, you can actually create custom APIs through software. And the neat part about that is that you can extend the functionality of Kubernetes to do things that it didn't do whenever you first installed it. And the hard part about that is basically the unknown unknowns problem. But because there's standards around creating these, Octant can actually read the configuration for those and make guesses about what the configuration looks like to make it look like it's built into the application.
That is very interesting. So, taking a step back, how would this tool integrate with something like the observability toolkit? I'm a massive fan, for example, of Honeycomb, of Lightstep, kind of distributed tracing, slicing and dicing events. I mean, they're clearly two separate areas, I guess, but do you see there's a certain harmony there potentially between the tools?
Yeah, there is a harmony. And as I mentioned before, we created the Octant plugin system to allow people to build software to allow them to integrate with other systems. So there's a couple things about Octant. One is, yeah, VMware definitely is paid to have this application built. But the way that we're looking at it, it's not a VMware specific tool. We don't want to make decisions about what you are using to interact with your cluster. So VMware has a metrics product called Wavefront. But guess what? Some people might want to use Prometheus or Datadog or something else. So we didn't code that into the application itself. And any screen almost in Octant, you can actually use a plugin to insert new content. So if you had graphs of historical data in Honeycomb or Datadog or even Prometheus, there is a way that you can build that in so you could show it in context with the information that we're showing.
That's very interesting. So I see a lot charity majors talking about half the battle with a distributed system is just understanding where the problem is. So I guess at the moment you're potentially looking at showing not only the kind of design time, but also integrating with the runtime of the systems.
Yes, that's correct. And I would agree with Charity on that. Is one of the hardest things of being a developer or even someone in operations is when there's a problem, how can I quickly solve it? And that's actually all we optimize for is how can I quickly solve it? And last week or a couple weeks ago, I actually did a 2-hour workshop on troubleshooting Kubernetes. And I went through this long thing I had about 4 or 5 scenarios. And the interesting thing is that I was able to turn on Octant, pointed at the cluster, and it instantly told me what the problem was. And that's what we're trying to do. If we solve these current things that we spend time on, then we can spend time on solving harder problems. And that's what I'm trying to enable people to do. You shouldn't have to fiddle with Kubernetes. You should be able to solve your application's problems, and Kubernetes just runs them.
Totally makes sense. Before we move on to perhaps other topics, if folks are looking to get involved with this project, what's the best way to join up?
If you go to github.com/VMware TANZU, that's VMware Tanzu/Octant, you can post in our issues, you can look at our README, look at our roadmap. And then also on Twitter, if you really want to talk to software, you can send tweets to Project Octant on Twitter.
Very cool. I'll put that in the show notes, make sure we got that there so listeners can follow up on that. Moving slightly to a related subject, hopefully, is what else do you think is missing in the Kubernetes ecosystem? We've covered kind of discoverability and understandability. Kubernetes is really a foundation for building other platforms on top. I've heard you say this, I've heard Joe Bader say very similar things. What do you think is the next thing we need to build on top of Kubernetes to make it more consumable?
Well, the issue is that whenever we start talking about Kubernetes in respect to what we're trying to deliver to our customers, unless you're a Kubernetes vendor, means that we went somewhere wrong. It's the same thing with Linux. I've seen Linux since the beginning, since the 90s. And now in 2019, what we look at is, yeah, we run a lot of Linux. Everything runs on Linux, of course. We don't talk about it anymore. The Linux was never the journey. And the same thing with Kubernetes is never the journey. So what we really need to figure out now is how do we move code from our IDEs and editors to wherever they need to run with the least amount of friction. So how do we make CI/CD implicit? How do we make security scanning implicit? How do we make building containers implicit? And that's what we're thinking about now is can we actually remove a lot of this complexity by just understanding what the user is trying to do and doing it for them? And yeah, I understand that people hate YAML. I mean, who likes YAML? YAML is not fun. And then people want to go and put templating languages on top of YAML. Oh gosh, what are you doing? What we need to understand is that the YAML is important. It's the same thing as you're writing software back in the 70s and maybe you're not writing in C. That's that newfangled language. What you're actually doing is you're writing machine code or some kind of assembler. And what we need to look at the YAML as is some kind of, probably as a machine code or some kind of assembler. And then in that time, in the last 40 years, we figured out how to write high level compiled languages. We figured out how to write high level interpreted languages. And then we figured out things like with LLVM and their IR to have the intermediate representations. And that's where we need to focus on Kubernetes, because we should be able to think in the concepts that we want and then have our tools generate this thing that is hard to read. If you think that YAML is the endpoint, we've already failed. So we need to think past that. But to get there, we need to understand what does and what doesn't work. So unfortunately for everyone listening, and actually everyone in the world, the YAML's not gone yet because we don't understand what the solution is.
Totally makes sense. I see a bunch of folks on Twitter discussing around serverless being at one end of perhaps the spectrum where you almost don't think about the platform. I know you've got some interesting tweets out on that. I see there's languages like Dark popping up, which is kind of almost a hybrid between, you code some of the infrastructure into the actual app itself. I mean, have you got any thoughts you're keen to share? Do you see that as separate to Kubernetes?
I have thoughts on serverless. They go from really simple to really complex. And with serverless, the first thing that we need to understand with serverless, just because we're saying serverless, that doesn't remove any of the complexity because serverless isn't one thing. If you're on AWS Lambda or whatever Microsoft is selling these days or whatever Google is selling these days, or you're using some of the IBM stuff like OpenWhisk, or even some of the pivotal stuff like PFS, or you're diving into Knative, oh my gosh. And understanding how these systems are put together, they're super complex. They have to make lots of assumptions and they have to put in lots of boilerplate and they have to do lots of coordination to make these things work right. So I think that serverless is an interesting solution, but I think that most people are thinking about it wrong. Serverless for serving your web applications with like in conjunction with like an API gateway from AWS, that's neat. We can do it. And you know what? I can also build a taco out of Legos, but who would eat that? And I'm not telling you to stop doing it, but I'm telling us to think about these better solutions. And I will give you a better solution for things that serverless is really good at. Imagine batch, but batch at a scale that is infinite for your point of view. At Capital One, and I can actually talk about this, is Capital One has a large amount of data in S3. And because they are a bank, what they have to do is when they're storing data in S3, it has to be encrypted. And us being humans, and we try to pay attention, but we're full of faults. We put data in S3 in AWS, and sometimes it's not encrypted. And what can we do? Well, serverless is great as this. Capital One created this thing called Custodian. And what Custodian does is looks at S3, or it just looks at configurations in general, and it tries to clean up messes. And I think this is a great thing for serverless because we don't have to allocate compute infrastructure to run this at whatever scale. And when I say Capital One scale, it's huge. So serverless is great at that. Serverless, if you think about streaming, where I have one piece of data and it creates some output and I need to stream it. And I need to not only stream it, I might need to stream it and then I might need to operate on it and then split it. So basically we have routing now. Serverless might be a great solution for that too, because I don't want to allocate infrastructure for that. I just want to say that I have a sink somewhere, it gets data from this thing, and then it spits out these other things. Now we can build cool things. Now, when we think about applications in serverless, though, think about what you're giving up whenever you do this. You're giving up all these other really interesting tools that allow you to build interesting applications because you want to fit in this little process and you need to be small and you should be stateless and a whole bunch of other things. So what I'm saying is that I think maybe serverless on the serving side will grow into something, but I don't understand right now if we've solved the problem at a level that I think we can say that, hey, this is a great idea and everyone should come do it. So not simple, like I was saying.
Yeah, something I've briefly bumped into and something we've talked about already is the understandability of serverless is really hard because not only have you got suddenly lots of things, potentially lots of small things, but I think I definitely struggle sometimes thinking asynchronously. Do you mean give me something synchronous? I can kind of track it down through. But if you're doing all these eventing, all these messages with all these, hundreds potentially or whatever of serverless functions, it's going to be really hard to understand what's going on there.
Yeah, and then we'll just build more orchestration systems. So now you have a serverless orchestration system. So really, is that any better than where we are right now? And I'm not telling people to stop thinking about these things. These are hard problems and they need lots of smart minds. But serverless is not a panacea. And my friend Kelsey Hightower, he's really talking about it a lot. And then he went down from serverless to no code, and people really embraced that whole idea. But what we need to think about is that these are fun, and Kelsey's having lots of fun as he's doing this. But we need to understand that you have to manage your own business, and listening to all of us so-called smart people out here talking about these things does not solve your problem. So what we need to do is us so-called smart people is start talking in a language that is better for people consuming our software and start talking in the context of their solutions rather than our technology.
That's a nice segue actually to something else I was keen to get your ideas on. Is I know you've done a bunch of work with the CNCF, for example. You were co-chairing at KubeCon. How do you see the landscape emerging? Because like looking at for example, the map, I can't remember exactly what they call it now, but the CNCF map, it's a huge amount of technologies there. And to a lot of people I work with, it blows their mind when they first see that map of so many things. How do you think the CNCF is going to, I guess, handling that? Do you think there's ways we can improve that kind of message for people picking and choosing what solutions they need to actually deliver business value?
Yeah, so I don't have a great answer for this. No, I don't have a happy answer for this one. CNCF roadmap. Oh my gosh, it's like an eye chart. There's so much stuff on there. You know what? I have software that I wrote that is on there, and yeah, pretty cool. But that chart itself doesn't really tell you what you would need to do to further wherever you are in your cloud native journey. And CNCF is actually thinking about this and trying to reorganize. And a couple things they've done is they've created these special interest groups around different topics. So I also happen to chair one called SIG App Delivery. And what we're thinking about in SIG App Delivery is, first of all, what's a cloud native application? Really harder than you might think. There are multiple components, and then we have to figure out all the pieces of cloud native application delivery. And then we need to figure out all the pieces around cloud native application delivery, whether how are we packaging applications together? How are we building containers? How are we orchestrating putting things into production? How are we ensuring that these things we put into production still work? how are we changing the interaction points from serverless all the way up to dealing with YAML from Kubernetes? So the CNCF is definitely a necessary thing, and I won't say it's an evil, but understand this. What we're trying to do, it's better that we are trying to figure it out as a community and as an ecosystem, even though, there's lots of money involved, rather than X company, let's say IBM, going at it alone and then deciding that they will only release this, but not this other stuff. So only they win. We should be competing on our solutions, not the tech to get us to our solutions. And we've realized this. So CNCF is great because it gets vendors, end users, and developers together. And hopefully, if we get all these people together, we can ultimately build better solutions.
I like that a lot. Say someone is relatively junior in their career and they're looking to get involved with open source, perhaps the CNCF, these kind of things. What do you think's the best route into doing that? Is it join a SIG? Is it maybe just read the docs, try and do the pull requests on the docs? What's the best way?
I don't like go read the docs and then go do the pull request on docs. That's an easy way of telling you to go jump off a bridge or kick rocks. What I would rather tell people is you want to be involved. Well, first of all, you can't get anywhere if you don't know where you're going. So this is definitely a huge thing where if you don't understand your destination, your journey is basically pointless in a lot of cases. So understand what you want to do and whether you want to actually look at CNCF things, because I know we have security and storage, and then we have SIG delivery, but then you have Kubernetes, and I don't have enough fingers to list all of the areas. Join a SIG meeting, read the mailing list, and join the SIG. And before you think about wanting to contribute, hear what they're talking about. And because what they'll do if they're actually tracking features, in Kubernetes, they have this thing called a KEP, a Kubernetes enhancement process document. And what it does is it actually writes out a problem and then it explains how someone wants to solve it. See if you can help with that. And then understand that there's other ways besides code that you can do things in Kubernetes. Like I said before, just telling someone to write documentation isn't super helpful, but there's tasks that need to happen around Kubernetes itself. Like there's a big process now for shadowing on the release people for Kubernetes because releasing Kubernetes is actually a big deal. You can go learn that. There's also something called SIG-PM. I think they're trying to build product managers or maybe project managers. I can't really remember which one it is, but there's a lot of people process in Kubernetes. So whether it's the person who actually makes sure features get delivered, but also the people who make sure coordination happens, or the people who are making sure information gets disseminated. So there's so many things to do. It's actually pretty interesting. But if you're a developer, and I'm only saying this for developers, if you're a developer and you want to start working in Kubernetes, just find something you like, go find that SIG and see if you can start working. But understand this, it takes software a long time to get into production in Kubernetes. I mean, it literally could be a year. So understand that and don't be too sad when it does take time because this is really important and we only release twice a year. Or we release more than that, but just understand that things take time.
Makes complete sense, Brian. Thanks a lot. A couple of more bonus questions that I've been keen to ask you just in general. I know you've got a strong background in Ruby and Rails. Is there anything you think we can learn from that sort of time to now? Because I've done a bunch of Ruby and Rails myself, loved it, got productive super quick, actually delivered business value super quick with a bunch of startups, but then also had to pay down some tech debt later on in my journey with Ruby on Rails. I wondered, is there an analogy with like sort of Ruby on Rails and where we're at in the cloud native ecosystem? Do we need a Ruby on Rails for cloud native?
Actually, I made a tweet about this a while ago, and I think I basically said that Kubernetes needs this Rails moment. And it doesn't really matter what you think about Rails or Ruby, but understand this. When David Hannemeyer Hansen came up with his 15-minute create a blog post video, and with the oops and all, people started looking at web development in a different way. And the whole idea of convention over configuration, which means that the application framework is set up in a way that the defaults will get you closer to success than having to do a whole bunch of configuration. You don't have to build up Ruby on Rails apps to begin with. You start with a great base and you start modifying the base for things you don't like. Kubernetes needs this whole moment as well. And what is that moment? That's actually a great question. What is Kubernetes Rails moments? Well, when we're building tools, we should actually think about convention over configuration. It should be easy, very, very, very easy to stand up Kubernetes on your desktop. And actually right now, I can think of two ways, and it is easy to do that. It should be easy to get your application into a Kubernetes cluster in a namespace. You shouldn't have to think. If you're running Java app, we know what a Java app looks like. We should be able to just deploy that. I want to deploy that thing. And we can say that it has state and it gets deployed a little bit different. So that's what we're looking for right now. And funny thing enough, I'm actually on, I don't know, maybe the 20th of next month in November. My keynote at KubeCon in San Diego will be thinking about the Kubernetes Rails moment. So I'll go into this for about 20 minutes, but it's something that even if we can't define it now, we need to understand that's what we're looking for, rather than yet another person creating yet another tool that interacts with no other tools, that introduces all these brand new ideas, which basically doesn't move the art forward. I mean, it's nice that we're understanding what doesn't work, but it's not great for everyone whenever we're not sure what tools to run.
Makes complete sense. And a final softball question. I know you're a big reader like myself. I love reading books, but tech books and fact books as well. Can you recommend any books? And they can be like any topic. It's totally open to yourself that you think are really useful for listeners now.
Okay, so let me see. Tech-wise, I haven't read a good tech book lately. I've seen some like decent ones, but nothing that I would recommend. Just go find something that interests you in your programming language. But as far as books go, there's two. And the first one is called Team of Teams. It's written by this ex-Army general. His name was General Stanley McChrystal. And what this book is about is teams of teams. So, you work on a project within your team, you have a bigger mission, and how do the teams work together to further this bigger mission? The story is told in the context of the United States in Iraq during the Second Gulf War, and how Al-Qaeda was actually beating the United States for a while, even though the United States supposedly had all this military might and all these other things. And it goes through how to build these teams and what they did. And there's actually a great example at the end in the 11th chapter about how do you think about team leadership. And I am definitely summarizing here, but a lot of leaders look at team leadership as like a chess game, like a game of chess. So you have a chessboard and you have an opponent, and you have pawns and king and knights and castles and queen and all these other pieces. And you as a chess player are moving these pieces in a strategic way to capture the goal, which is to basically capture the king. It's kind of neat. But when you have people involved, that's not the same. People are not chess pieces. So we need another analogy. So the analogy they come up with is about people leadership is like gardening. And if you have a garden, what can you do with that garden? Well, you can make sure the soil is right. You can pick the best seeds, and then you can till the ground and you can water them correctly and give them the right amount of fertilizer. But you don't grow plants. Plants grow on their own in the best situations. So as a tech leader or a team leader of any sort, what you're doing is creating the best situation for either your reports or your other team members to grow. And whenever you approach leadership like that, then I think you'll get better results than thinking that you're just basically this tactician that will actually make everything all right. And then another book that I'm reading is called The Mathematical Universe. And I love space books, and I love physics books and chemistry books and quantum physics books. But what this book is about is a story about how our universe is built on mathematics. And I'm a huge math person. I just think math is the greatest thing. It's probably why I got into software development anyways. But it's nice hearing about how people are exploring our universe with mathematics. So I really like that.
Awesome recommendations. Thank you very much, Brian. I appreciate your time today. Thanks for joining the InfoQ podcast.
Oh, no problem. Thank you for having me.
What is happening in the programming language world? Which language has gained wider adoption? Check the Programming Languages Trends Report to make informed mid- and long-term decisions, or to choose wisely where you invest your time.